Okay, hello everyone, and welcome to today's webinar. Today's webinar is the benefits of modern continuous delivery with Spinnaker and OpenShift. My name's Bo Roberts. I run marketing at OpsumX, and I'm joined today by Marky Jackson, our director of open source software, who will be our speaker today. Just a few announcements and some housekeeping before we get started. If you have any questions during the presentation, please type them into the question box in the Zoom control panel at the bottom of the window. We'll address any questions during the presentation when it's appropriate, but most of the time we'll answer the questions during the Q&A session at the end of the presentation. We'll also be asking several poll questions during the webinar today, and these questions, we ask these questions in all our webinars just to give our presenter an idea of who's in the audience so they can customize and adapt the presentation a bit to the specific audience. These questions are completely optional, but if you can answer them, that would be appreciated, and we'll share the poll results with you when it's appropriate. Okay, so let's get started. Let me go to the next slide. Okay. Okay, so for those of you who may be new to OpsumX, we're a venture-backed startup. We're based in Silicon Valley in Sunnyvale, California. And we help enterprise organizations modernize and transform their software delivery with Spinnaker. We provide an enterprise-ready distribution of Spinnaker called Open Enterprise Spinnaker. We also provide managed Spinnaker as a service, as well as Spinnaker onboarding, training, and support services to help enterprises adopt and scale continuous delivery and Spinnaker in their organizations. Okay, so let's move on now. And before we get started, as I mentioned, we're going to start off with a couple poll questions. So I'm going to launch this poll question, and if you guys could answer these, that would be great. As I said, they're completely optional, but they're pretty standard questions. So first one, are you currently doing continuous delivery? If yes, with what percentage of your production applications? And the second question is your organization currently evaluating or using Spinnaker? So yeah, anyway, I'd like to start off with these questions. Just gives our speaker an idea of who's in the audience, and we'll share the results with you as well. So I'm going to give this a few more seconds, maybe 5 more seconds for people to do their vote. And okay, so if you'd like to vote, please do that, and we're going to close it in 3, 2, 1. Okay. So I'm sharing the results now if you're interested, and so looks like we've got a good mix of people here in terms of people who are doing continuous delivery, not doing continuous delivery, and same thing with Spinnaker. So, okay, with that, I'm going to turn it over to today's speaker, Marky Jackson. And Marky, why don't you take it away?
Awesome. Thank you very much for that, Bo. I really appreciate it. Can everybody hear me okay, first and foremost?
I can hear you fine, Marky.
Awesome. Thank you. I see people saying yes. So I would like to thank everybody for coming. For those that don't know me, I am the director of open source software. I'm involved in a lot of different communities such as Kubernetes, Jenkins. I am a CDF ambassador. And what we're going to do today is we're going to talk about not only just Spinnaker, but the different ways that you can deploy Spinnaker and which ways that we have seen that have really been beneficial to the larger community. But before we get started, for some that may not know, I'm going to give a little bit of history of Spinnaker and just a little bit of an overview. We know that this started by Netflix, and the development started in 2014. For anybody, I mean, I think everybody pretty much knows who Netflix are. This was put into production in 2015, this being Spinnaker. And then they open sourced it in 2015. It's really a new sort of open source project that they had done, and it's super mature. There's a growing community behind it. Many companies are using it. It's backed by Google, Netflix, Microsoft, Veritas, Target, Kenzen. We'll talk a little, for those that don't know about Spinnaker, Spinnaker is part of a delivery pipeline. This does your CD, and it takes care of all of the deployment phases of the given applications. Spinnaker supports application management. It can be used in conjunction with continuous integration technologies like Jenkins, CircleCI, Travis, Bitbucket, and more. Using Spinnaker, you can deploy apps that are supported by all major cloud providers such as AWS, GCP, Azure. I know that there is some work being done with IBM Cloud currently as well. And of course, Kubernetes, one of the big ones. What is Spinnaker? So Spinnaker is an open source multi-cloud continuous development platform. It's basically used for building and releasing software at high velocity with confidence. It's designed with pluggability in mind. And again, we said it all supports all major cloud providers. This will allow you to create pipelines that run integration and system tests and then deploy that to a given environment. You can set up webhooks, get events like Travis and Jenkins in your Spinnaker pipeline. You can also create and deploy immutable images for faster rollout, easier rollback and elimination of hard to debug configuration drift issues. I really like this last part because for all of us that have done software development and you're building a Docker image and you need to deploy this and you really need to have a really good set of automation tools as well as the ability to roll back when you've introduced a bug. This provides a lot, Spinnaker provides a lot of that. There's a large community behind this, such as Netflix, Google, there's OpsumX. One of the questions you may get is, why would I need to use Spinnaker? The goal of Spinnaker is to make reliable deployments. So I get asked this question quite often because I'm a member of the Jenkins community and one of the core contributors. Why would I not just use Jenkins and not use anything else? Because Jenkins does allow for continuous deployment. I answer that this way. A lot of times when you build CI and CD in Jenkins, Jenkins does CI very well, and it can do CD. However, you have to rely on some plugins to do that. You also have to rely on code knowledge. You're going to have to write your own code for various deployments, such as Kubernetes. Whereas Spinnaker really does this out of the box, and it integrates perfectly with Jenkins. So what that does is it lowers the, for an organization that may only have a certain number of people on a team, this, makes it more accessible. It also lowers the overall cost. Another big selling point of Spinnaker as far as usage is the ability to allow for easy rollbacks. So this actually will take, I'll give you sort of a use case is, I know that a given Docker image was built, and this is our last production image. We've now introduced a new image, and we think we've got all of the bugs worked out, and we deploy it to prod, and there was some edge case that we did not know about. Spinnaker allows you to easily roll back to your previous, if you're using a Docker image, say, as your previous sort of gold standard, it allows you the ability to roll back to that. With the built for high velocity, Spinnaker gives you the ability to do this really fast and to do it reliably. That's one of the benefits of having Spinnaker as a CD, because you can now use this tool with confidence to say, okay, I know what I'm going to roll out. And if for some reason there's some edge case that we didn't catch during, QA, we can easily roll back. And because we can do this with ease, we can do this a lot faster. faster. The flexible pipeline management system allows you to use all kinds of different things like parameters, things like triggers, gated approval processes. It allows you to use this throughout the pipeline. So it gives teams a lot more flexibility to do what they need to do out of the box, whereas opposed to in Jenkins, which it's a great tool, but you have to write a lot of that code to do that. And sometimes organizations just don't have the time or the flexibility to be able to do that. One of the big things about open source projects is the project is only as good as the community that supports it. Spinnaker has a very large, healthy community with a lot of active contributors. So that makes this project also very valuable. There's other projects that come to mind when I think of a healthy, vibrant community. Jenkins has a large community. Kubernetes has a large community. Spinnaker does as well. Because this supports all major cloud providers and it also supports on-prem as well as Kubernetes, you now have a lot of flexibility to do the things that you want because cloud it's a major thing. There also are some instances where there's an air-gapped environment and you need to do that. Spinnaker also supports that as well. Feature-rich, every open source project is, I said, it's only as good as the community that supports it. That community that supports it also is the same people that write the features. And there's a lot of value within Spinnaker because of the community writing these features. Things like CI integration, CLI setup, and admin console. There's the virtual machine bakery, and I'll cover these a little bit more. There's role-based access, so our RBAC. We have allow list execution windows. We have monitoring integration. There's a notification and manual judgment with all kinds of plugins for that. So you'd say, some people will say, I want Slack a message to send a message to a channel and somebody can respond to allow a pipeline to keep going. Same thing with Jira, so you get that same management here. And there's also Chaos Monkey integration to really stress test your environments. So we'll talk a little bit about the architecture of Spinnaker. It consists of a number of components in microservice architecture. Those major components are Deck. This is the UI that you use to access Spinnaker. There's Gate, which manages all the API calls. There's Orca, and this is the orchestration engine that's responsible for pipelines and other operations. We have the cloud driver, which is responsible to make the calls to the different cloud providers. We have Front 50. This holds all the metadata of applications, pipelines, and so forth. There's Roscoe, which is responsible for producing the immutable VM images. Igor is responsible for triggering the pipelines. Echo handles all event triggers, Slack notifications, and emails. Fiat is responsible for the authorizations in Spinnaker. Kayenta is responsible for the canary analysis. And then Halyard is responsible for managing all the Spinnaker services and configurations using the CLI. And this is sort of an overview of what that architecture looks like. So some people may ask, why Spinnaker? This kind of gives you an idea of how that pipeline sort of works, where you do your code check-in, you'll have your continuous integration, you'll bake your image, you'll do the deployment, and then you'll do your prod deployment and test, any hot fixes, and then canary, and then you're basically live, so you're smiling. Methods of installation. So this is the key part that I wanted to touch on in a lot of what this webinar is really for. So a lot of different ways that you can install Spinnaker. So there's the local Debian. The reason I recommended that this is standalone and not recommended for production is there'll be some individuals that will be like, yeah, this is great, let's try it. Okay, it worked, now let's put everything there. Local Debian is not recommended for your production environment. You have the distributed methods such as Kubernetes, OpenShift, AWS, and GKE. This webinar, I'll focus more on OpenShift. You have a Helm-based installation option, an operator-based installation. Oop, go back there. And I'm going to talk a little bit about Helm and the operator, and that's more what this webinar is going to cover. So for those that may not be familiar with what Helm is, the basic idea of Helm is to enable reusability of Kubernetes YAML artifacts through a template. So Helm under the hood uses Go Sprig templating that allows you to have sort of overlays, or in the case of Helm, these are your chart YAMLs. The benefit of Helm is that it's super easy to deploy an application and update the application using the Helm, the YAML files. If anybody's used this and you have to update your charts, your chart YAML, you can set all kinds of awesome templates to templatize ways to do upgrades. The Helm, everybody knows that the Helm project has got it's considerably popular. There's currently Helm.3 version 3 that is out, and that's basically for deploying application workloads with different settings and items such as that. OpsMX does support the Helm-based Spinnaker installation as well. What is an operator? So an operator is something that it's a method of building and driving applications on top of Kubernetes. You can easily use Kubernetes tools to help solve the problems of a complex application. The benefits of using an operator is that you can operate a stateful application through writing a custom controller with domain-specific knowledge built into it. I'm going to go a little bit more in depth with what I mean by this. An operator allows the automation of infrastructure that you need to run containerized applications. And it's really, an operator is really meant, if you think about it, the construct of I'm part of a DevOps team, or I'm part of an ops team, and I do certain things, right? If let's say there is let's say I have a Cassandra cluster. And in that Cassandra cluster, there's a ring, and in that ring, I have 6 nodes. And let's say one of those nodes goes down. As a DevOps person, I need to run a series of steps to see what's going on. Is the ring healthy as a whole? If I add a new node to that ring, how am I going to propagate the data? And things like that. What an operator does is an operator takes some of that knowledge that you have as an individual and automates it. So like when I just used that Cassandra example, that will allow me to have the operator do exactly what I just said. And that's really huge for a lot of companies because it's a cost savings. This is a hot topic right here, Helm versus operator. And a lot of people have different feels about why would I use Helm versus an operator, or vice versa. So Helm and Helm and operators represent 2 different phases in the application workload on Kubernetes. Helm's primary focus is day 1 operations of deploying a Kubernetes application or artifact into a cluster. On the other hand, focused on day 2 is really like, if you think of things like Postgres or Cassandra, this is where we need to start thinking like, how do I address those day 2 management tasks? And that's where the operator becomes a really value add. So you can kind of look at it sort of like this. Helm does my day 1 operation, and then the operator actually manages the task for the stateful and complex workload. So we're going to kind of just go into what the Spinnaker operator architecture looks like. It has two important components, and those components are a CRD, which is the custom resource definition, and then there's the OEM, which is the operator lifecycle management. So the CRD acts as the brains of the operator. All the data that you want to represent for that application and the core bits are stored in the CRD. And then the OLM it's responsible for upgrading and dependency resolution, multiple installs of versions on the same node. This handles sort of your thought process. And you can kind of see where that looks like. The Kubernetes API is communicating with the Spinnaker operator, and then the Spinnaker operator is now working on the Spinnaker pods. And it's sort of this little picture here gives you sort of a high level overview. So how would we deploy a Spinnaker operator? It's really simple. We're going to first register the CRD, and then we'll apply it. Then we'll set any RBAC that we need. We deploy the operator, and then we create an instance. It's very, very straightforward. And this is kind of what a CRD manifest look like. We're going to basically call out our API versions. We're going to use, in this particular case, we're using the OptimX Spinnaker operator. I know a lot of companies have come out recently saying they've got an operator. We actually have had an operator for quite a long time, so we're really proud of that. We have our service account that you basically use so the operator can operate at a level from a cluster standpoint. And then here's what our operator looks like from a YAML perspective. And then here's our deployment. This is for deploying the OptimX Enterprise Spinnaker. So what would be some of the benefits of using a Spinnaker operator with OpenShift? So the ability to have automated releases and have a flexible pipeline builder with built-in policy controls that dynamically alter multi-service composition application deployments. This gives a lot of flexibility to a DevOps team that's handling a lot of the deployments. Having an operator is massive. When you think about having an operator on Spinnaker in OpenShift, you've now just really revolutionized the control that the DevOps team can have without having to spend multiple, having multiple people worry about releases or ways to actually revert releases or rollback. Another beauty of the operator is Red Hat certified and tested. So every operator that's released through the operator marketplace for Red Hat has to actually be certified before it can be advertised there. So having that done is an extra level of confidence to a given organization when they're using this structure. So having enterprise grade solution for CD, as I talked about in the beginning, when we think about CI and CD, and a lot of organizations will put that CI/CD into one tool, and that's Jenkins, and that's totally doable. However, it requires the use of plugins. It requires a lot of code, specialized code, and sometimes that code, you get drift and things like that. This is a way to get around that. Another beautiful thing about this is for organizations that are working on compliance issues such as SOX or HIPAA, you know that when you have something certified by Red Hat, you're adhering to these compliances. And then one of the easy and most beautiful parts about this, anybody that's managed a Kubernetes cluster and has had to, in production, and has had to upgrade that cluster to whatever version you need to upgrade. Let's say you're going from version 1.16 to, or excuse me, 1.15 to 1.16, and you know that there's a lot of API deprecations within that. That requires a lot of work for the team, a DevOps team, to have to manage all of that complexity. This is a beautiful, more easier way for that team to be able to do that. Because you're using an operator that has all of this built in, you have the ability to now do easier upgrades. So I threw up a few different URLs here, such as a Git URL for using OptimX in a Spinnaker tutorial. We have a lot of blogs at OptimX that we cover how to install an operator, how to install Spinnaker using via Helm. We also have Slack support, and you can also reach at OptimX at hello@optimx.com. So that kind of covers this talk but really what I was more hoping to get out of this is the questions. A lot of times people will have questions in terms of, well, wait, what do I do? What if I want to do this? Or what if I want to do this? And this is really what I want this webinar to be, is the abilities for people to ask questions on setting up various things, or questions on, well, I tried to do a Helm install and it didn't work, and things like that. So I'm going to go ahead and I'm going to turn it back over to you, Bo, and
Okay.
I will answer any questions.
Okay, great. Yeah. Yeah, everybody, as Marky mentioned, we're going to do the Q&A now. If you have a question you'd like to ask, as I mentioned earlier, there's a Q&A button at the bottom of the window. You can simply click that button and then type in your question. In order to give you guys a little bit of time there, I wanted to actually do another poll question. And this is another poll question we do, but it's really more of just a way for us to know who would like to be sent the presentation file. Oftentimes people ask us if they can get a copy of the presentation slides. We don't make our slides, publicly available, but we're happy to send them to you after the webinar. So a couple other things I wanted to note that you can also have us follow up with you about is Spinnaker training, onboarding, or support services. As I mentioned earlier, we also have a enterprise-ready Spinnaker distribution called OpsMX Open Enterprise Spinnaker. And we also have something called Autopilot, which is a continuous verification platform that works with any CI/CD, not just Spinnaker. So if you would like to schedule a demo of OES or Autopilot, you can also select that in this poll question, and we'll follow up with you. So anyway, I'll leave this poll up for a little bit, but we will move on to the Q&A now. And let's see here. Let's see what we've got. Okay. Okay, Marky, the first question is basically, what are the pros and cons of using an operator? It kind of speaks to maybe what you were speaking about before, but maybe a little more specifically about pros and cons.
Yeah, so operators, you can still hear me, right?
Yeah.
Oh, awesome. Operators give you the benefit of handling a certain set of tasks for a given microservice easy, right? So if you think about any microservice that you may have control, or you maybe have to watch out for. Like I gave an example of using Cassandra, but let's say we have Redis, and let's say I have Redis with a leader, and then I have 2 workers, and let's say one of those workers goes bad. Well, then I need to now go find out, did the secondary worker take over? And then I've got to bring up another one. So that's a manual series of steps that I need to take. An operator, when configured correctly, will do those items for you. So I could, as I described those tasks, like I would need to make sure that the secondary is now taking on the task. I need to then build another node, and then I have to put that back into the cluster. I then need to move the traffic back from the secondary to the primary worker. That's all manual steps. But if I have an operator, the operator does that for me. Now, when you think about Helm, Helm's not going to do all of those tasks for you. However, if I need to install a Redis cluster and have a preset list of configurations, that's what Helm's going to do for me. It allows me to get that node or that cluster set up with minimal configuration, because it's already built into the YAML and the values .yaml file, which holds all of the configurations for a given chart. So that gets me day one. It gets me my cluster working. But when I need to manage my cluster and check the health and do certain things, Helm's not going to do that for me. Hopefully that answered that individual's question.
Sure. Are there any cons to using an operator? Marky?
Yeah, well, having used an operator in production, there are some cons. Number one is understanding as a team, what do I want the operator to do, right? So a lot of times certain operators will do things out of the box, but what if I want to expand on what it does? Well, then you'll have to have a little bit of knowledge of how the CRDs are written from a code perspective, and you need to, update that. That's one of the main cons that I've seen working with various companies is they like the ability of what an operator does, but when they want to add something to it, then there's a sort of a learning curve, and that learning curve is steep because it requires understanding not only how the Kubernetes code base works, but how for whatever given application you're doing. There's also a lot of really cool tools put out there by Red Hat to help you build and customize operators. So using those tools get you a little bit closer, but that's been one of the pain points that I've seen in companies.
Okay, great. So we had another question, which is pretty similar to what you were talking about, but maybe it's a little more specific. It's basically, why would I choose an operator over Helm? I know you were just talking about that, but maybe I can go a little bit more into that.
Yeah. So when you do a deployment of a given, at whatever application it is, or Spinnaker, you have two items that you want to do. Number one is you want to get that deployed and up and running. That's what Helm does for you, but that's where it stops. Now, when you want to manage that Spinnaker cluster, now you want to think about how you're going to, what are the tasks that are going to be needed to manage that cluster. So for example, let's say you've deployed this to OpenShift and your Halyard pod goes down. Well, what do? If it's a Helm deployment, you as the individual person on a team are going to need to go in and start to debug what's going wrong. Why is that pod down? Whereas if you're using an operator, the operator for Spinnaker specifically is see that the Halyard pod has gone down and it's in a crash loop. It will automatically investigate that and then will grab the configuration, completely lower the node, the pod count to 0, and then we'll bring it back up and try to fix it automatically. So the beauty of and this does this in more of, milliseconds. Whereas if you have a person that has to come in and try to figure that out, in a production environment, that could be time consuming and you could be, affecting customers. So to put that all in a nutshell, Helm gets you the day one, I need to deploy this. That's what Helm gets you. But that's where it stops. The operator gets you the automated day-to-day task.
Okay, great. Okay, if anybody else has any other questions like to ask Marky, please enter those now. If not, I guess we will wrap things up. But wanted to let you know that we will be doing a follow-up to this webinar and doing it on a topic, related topic, but a little more technical and with a demo. We'll be doing that in the next few weeks. Marky will be doing that. So encourage you to keep your eyes open for invitation to that webinar. I'd also encourage you to go to opsimx.com and check out our webinar calendar. We've got a lot of good webinars coming up in the next few weeks. So definitely take a look there, as well as our resources section and our blog, which have a lot of great content about Spinnaker and continuous delivery in general. So, okay, let's see. I'm not seeing any other questions. So, Marky, did you have any final thoughts you maybe wanted to share with the audience before we maybe wrap things up?
Yeah, I definitely do. So as Bo had said, that there will be another webinar that will be covering up what we talked about here a little bit more in depth. And what that will show you is how to deploy Spinnaker using the operator, using Helm. And I'll really, as I was just saying, those kind of day one, day two things, I'm going to show that in sort of real time what that looks like. So do stay tuned. That will be coming up in the next few weeks. I would also like to close my part out by saying sometimes people don't like to ask questions because they feel, shy or whatever it may be. Totally get that. I am a very approachable person. You can find me on Twitter at MarkyJackson5, and my messages are always open. I'm a super helpful person. So if there's a help that you need or a question that you have, do not hesitate to reach out to me. And I really thank everybody for joining it. It's awesome.
Yeah, yeah. Thank you everyone for joining us today. I think we're going to wrap things up unless we have any other questions. If you have a question, submit it now. If not, we'll probably wrap things up in another 5 or 10 seconds. So anyway, as I mentioned, please check us out at optimex.com for our webinar calendar and other resources that are there for you. And looks like we don't look like we have any other questions. So I think we're going to wrap it up for today. So thank you everyone for joining us. We appreciate it. And we hope you have a great rest of your day.
Thank you, everybody.
Thanks, everyone.